Hello everyone, I'm Miles Frantz, and today I'll be walking through the SQL Injection Attack Lab by Seed Labs. And SQL Injection is also called SQLi or SQLi for short. And throughout this video and demo, I'll be going between each one and the other intermittently. So I will describe what SQLi actually is and why we should actually care about it. Then I'll actually run through the Seed Lab demo and show you every step of it. And then finally, I'll wrap everything up. So what is SQLi, or SQL injection? Well, to go back to get a basis, SQLi depends on the interaction a user can have with a database. So how does a user actually interact with a database through normal websites? So let's say you want to visit youtube.com. You'd use your personal computer and type it into the web browser. And throughout a couple of different hops and steps, your computer will actually connect to one of the many YouTube web servers. And then that web server will attempt to select information or select your personal information from its own database using SQL. And if anything was found, the database will return whatever information was selected to the web server. And then after that, the web server will create a custom YouTube page that's tailored to your profile. So that could include things like your preferences, any channels that you've liked, commented, or subscribed to. It would have all of those there. And specifically, SQLi, given by the name, depends on SQL injection. And the SQL injection is at the web server, where it actually creates the SQL query using the information you passed into the server. So where does SQL come in? So SQL comes in throughout the tech stack. And for this demo, I'll be going over the LAMP tech stack, which is out of date in some circles, but it's still very popular to today. And it's called LAMP. And LAMP is an acronym that stands for Linux, Apache, MySQL, and PHP, where Linux is the base operating system, Apache is the web server, MySQL is the interface for the database, and PHP is the programming language that will create the SQL and also create the web page. So given we have this small web form shown right here with two inputs, username and password. And this is actually the web page that I'll be showing in the demo later. So once we have this web page, assuming the user passes in their, let me get a different color. Sorry about that. Assuming the user passes in their username and their password, they'll then hit login, which sends that information to PHP, where it'll create a SQL query like this. Now I'll go over the exact SQL query a little bit later, but for now, you just need to know the username goes into this variable and the password goes into this variable. And you can tell it's a variable by the $sign at the front of the word. So next, once we have the SQL query, the web server will actually execute it on the database itself. And once the data is selected, it'll be returned, and the web server will do some sort of creation and pass it back so it can be rendered and passed to the user who visited the website. So we've talked about lightly what SQL is, and we talked about the tech stack, but what is the injection? And the injection actually happens solely because the input is not sanitized, and it sort of allows the user to interact directly with the database itself without any intervention between the user and the database by the developer. So we'll use, to explain this, we use the same query as before with the input uname as username and hash password as a password. And we'll also bring in this table, which you can think about it like an Excel sheet. Because if you look right here where I'm highlighting, it has the column headers. And those are the names of each column. And they're divided by these lines right here. And if you look at the information below it, you can see each line in the terminal represents a different record or different row of information. And we select information, or if you can see, let me clear this up. We select information in this query by naming it in the select section. And then credential is the name of the table. And for this, this is what credential table holds. And the more important part is the where clause, where we actually have to filter information. So if we pass, so say from the form before, we passed in Alice and password as username password. The sample query would be generated below, and we'd select information where the name is Alice and the password is password. So assuming password is correct and that's her password, which is a weak password, it'll return this information right here. And we know that because it's specified the name by the string Alice. And it will only return one record because that's a unique value, so we can see in the table. Now, the injection part is where someone tries to put in a variable or string that's not a normal name or field of entry. So if we look here, we can see Alice apostrophe semicolon pound or hashtag is sent into the string, and that's definitely not normal. And the generated SQL would look like this. And this actually changes the query a lot, where if you can see by the syntax highlighting, the pound symbol is a comment for SQL, and once the pound symbol is there, it'll comment out the rest of the SQL query and essentially disregard its results. And I'll go over a little more of it later, but once we put this in, this will effectively change the query and rewrite it to select all this information where name is Alice without any information about the password. And once this runs, it'll still return the record of Alice. And this is without any password authentication or any kind of authentication in that. So this may seem like a very generic vulnerability or very like a popular vulnerability, and it actually is, but that doesn't explain why it's still here, why we should care about it. So as shown by this comic strip here, if you quickly read it, it'll show, or it'll say that a parent named her son Robert Drop Table Student. And then it'll show later that whoever called lost the current year's student records. And so if we examine the name a little closely, we can see that it's Robert Drop Table Students. And since we shown in the previous example how we could comment out part of the SQL command and change it to what we want it to do, in this same example, the drop students command in SQL actually drops or deletes the entire data table that is named students. And actually, on a side note, during my internship, I've heard of a story or possibly a rumor where someone actually ran this in a production database. And this was from a company unrelated to the one I was at. It was a friend of a friend. And luckily, they had backups of the database and information. But unfortunately, this just goes to show that examples like this do happen in real life. And at least for this instance, it was an accident, let alone any malicious users. Now, for the more malicious users and why we should actively look into this, it's still very popular, and it's even in the OWASP top 10 application security risks. And SQL injection is the #1 as of 2017. And OWASP is a very public and very big security group or organization that sets up a lot of guidelines and a lot of security practices that people should watch out for and people should use. And a lot of companies are hit by SQL injections. And shown from this photo, Sony Pictures was actually exploited by SQL injection. And it was noted that the people who ran the exploit got away with millions of records of information. And this information includes usernames, first names, last names, personally identifiable data or address or anything that Sony Pictures had on hand. So it's pretty big vulnerability for a big company like that. So now to the demo. And here we can see I have, you see I have a virtual box. It looks like it's still loading. There we go. So if we see here, we can see the Seed Labs username and password and the login form for the web app. And before we do that, for this lab, we actually do have insight into the database. So let's take a look at that real quick. So I'm currently logged in on the MySQL session, and that can be done quickly If I look for the current tables and users, I can see credential. And so if I run a generic query from the table credential, the asterisk will select anything. So it'll select all the columns. And unfortunately, I typed the table name in wrong. Let's see. Unfortunately, I'm having issues connecting to. Oh, my apologies. Of course, SQL is decently complicated, but this should not be a complicated step. So if we look here, after I actually run the query, we can see all of the information that's tabulated. You can see Alice, Bobby, Brian, Sammy, Ted, and admin, all with EID, salary, birth, and the rest of the information. So, for example, for this website, say we want to log in as Alice, but we don't know our password. Or we're Alice, there's no place to reset your password, so you want to log in yourself. So how do you do that? So fortunately, since we also have the back end of the website, I'll show you what the query looks like in the back end. So this is definitely stretched up, and I hope everyone can read it. But if you look here, this is the back end of the login site is just a simple select that we saw before. And the username goes in name, and the password goes in the password field as well. So if we want to break it, like one of the samples I showed before, you can type Alice. Unfortunately, I already have some sample tests that I tried. And I'll walk through this to make sure everyone understands. But if we just try running Alice, apostrophe, semicolon, pound, it'll log in. And it'll bypass the password that I didn't enter purposefully. So if we walk back here and I paste the same exact thing where name should have been, you can see I preserve the single quote, which in SQL is necessary for any kind of string, or yeah, it's necessary for any kind of string. And I use a semicolon to end the current SQL statement. So the SQL will actually only consist of this circled section, whereas this portion will actually be commented off and could potentially be another SQL statement if this comment wasn't there. Yeah. So we're able to successfully log in using or into Alice's account without using her password. But say we wanted to do this over the command line to potentially script the output. You could essentially copy and paste the same thing into the terminal. So say we use curl, which is the Linux, or one of the Linux commands, which actually lets you pull the raw HTML and JavaScript from any website you want. And if you can see here, request looks pretty familiar and along the lines of what you would expect from the form. However, if you see here, and it's a little out of zoom, so let me try zooming in real quick. I guess it doesn't want to do that. So if you see the percent 27, 3B, and 23, these are all transferred from their regular character to a URL encoding. And if you remember from before, from the actual text I copied, it was Alice, apostrophe, semicolon, and hashtag or pound. And the 27 represents the apostrophe, the 3B represents semicolon, and the 23 represents the pound. So if we clear that, we run this, we'll be able to get the same web page from the command line, or from the website on the command line. And just to double check, if we look for the SANIT or the SSN, we look for 102.02. So if we look, yeah, the SSN buried in the HTML is this. And so let's say we wanted to run, so while we're trying to log in, we also wanted to drop a table. So let's say we wanted to try dropping the credential table while we're trying to log in. Unfortunately, that will not work. So if you can see, it throws more of a generalized SQL syntax error. So the way this is configured in the back end, if we look at the back end code quickly, yeah. So we see, sorry, I had this pulled up just a second ago. There we go. Yeah. So the way in Python, the way this method is called, it is only limited to one SQL statement. So like I said before, if we add a semicolon, it'll close the SQL statement, and that's necessary. But if we try doing something else, that will break just this regular method, which is limited to only one query at a time. All right. So we've logged in as Alice, whether we are Alice or not, but assume for this scenario we are Alice, and we feel like we should make a lot more money, whereas 2,000 units doesn't seem enough, but we want to make more. But currently we only have access to the edit profile, and assuming that this web app is as weak as it was on the login, we could easily reset the salary. So if we set the oh yeah, unfortunately I do have a lot of preset examples, but I will walk us through this. So using similar, before that, I should show you the update query. And this query is run in the back end of the edit profile. So if you look here, we update the table credential, we set the nickname to a specific variable, we set other variables where the ID equals a specific ID. So if we're trying to inject another variable in here to be set, all we need to do is add another copy, something like this. So if we set, pull this up. So if I actually put this in here, it looks like it's a normal query with nickname here, a regular single quote, a comma, and the new column that should be edited is salary with 8675309. And that's a valid query. So if I set this and save it to execute it, you can see that the salary is 8675309. So the SQL ran successfully. So say our coworker Bob, let's say he hasn't been working that hard and we don't think he should be earning as much money as he does. Now, since we've seen how loose or how broken the query is and how much we can break it, we can actually break it in the same place that we changed our own salary. So I'll quickly pull up what it should be, and then I'll explain it right to us. So if I put it in the nickname field, which is the quickest field I found, we can see we essentially added the salary as 1, and we added a where conditional for his name, and then we stopped the rest of the query. Where, like I said earlier, you can't run multiple queries at the same time. However, we're just resetting or creating a new where conditional for the rest of the query. So if I run this, that should have updated. And if we look quickly here, you'll see his salary increased or decreased from 2,000 to 1. So we know that the command ran successfully. So now say we don't think it's enough. Say we want to change his password. So if we look at these passwords, we can see that they're not a normal password. We can see they're not just a string. Just to keep things going, I'll say that these are SHA-1 hashes of passwords, which I believe we've talked about previously, but they're essentially a one-way operation that changes a string into a unique string, where it can't be reproduced unless you have the same exact string. And say we want to change Bobby's password, since he definitely hasn't been doing enough work and we don't think he should be getting, or we think he should be locked out. And that's pretty simple. Let me put salary update back in, and we can actually no, Bobby deserves a lot less. He's getting -$25. Unfortunately, knowing SQL, SQL provides a hash function itself. So if we type in password equals SHA of whatever string, that'll set the string as whatever hash we want. So let's say we set it to, let's say we set it to Alice. So he probably won't know what that password is, and only we will know that password. So if we try executing it, we can't see any difference, but if we rerun, we can see between this line and this line, they're both Bobby's passwords, but it changed, and that's likely, or that's clearly from the password update. So just to verify, we say Bobby and we say Alice. We're able to log in and see that Bobby actually owes 25 units of something. So fortunately, there are ways to mitigate this. Sorry. There are ways to mitigate this. I'll be going over I'll show you 3 different ways, but I'll actually only do one of the ways. So if we see here, there we go. So one of the ways PHP actually has set in the language itself, it actually has protections against SQL injections. And if we look here, which is, apologize, it seems, there we go. Now we can see it. So the HT access file will be run whenever the server starts. So these options will be captured and executed when you start the server service. And for this exercise, I've actually turned the magic quotes off. And this actually will try to escape quotes when they're entered in. So we can't just stop a string section. And that will effectively stop us from getting out of the string and adding our own custom SQL commands. And then if I zoom back out, we can also do here we go. So if we see here, let's see if we can zoom in to see only one of them. There we go. So you can ignore this echo. But if you see here, this is the safe file where the main difference between the 2 sections and the 2 files is the safe file prepares a query and it runs the function bind parameters. Where if we look solely at the old file, the unsafe, we'll see PHP essentially just creates the SQL as a string and keeps concatenating values onto the string or placing values in the string. The prepare statement actually specifies what variables are going to be set, and it will automatically try escaping certain characters. And so if we see this first argument is specifying what the following arguments are, and S specifies that it's specifying values for strings. And if we see the input nickname, it'll be set to the first question mark, and then input email to the next, and so on. And that's another way that you could potentially mitigate SQL injection. So for the third example, I'll actually run this one. Look here. if I can quickly get up to it. There we go. And this is actually, oh. So this is actually a similar method to the one I just showed. And since this one doesn't actually show it, I'll quickly, yeah, I can quickly describe it, and I'll actually run this one. But the other method is essentially running a PHP string, or a method that makes a string safe. If you run So if you run this method on any string, it'll try escaping all of the hidden characters that can be in a query. And it should mitigate any of the, or it should mitigate a lot of these injection attacks. Excuse me. So if we go back and just to make things quick, so now I've run this make command, which all it does is it copies the safe home PHP to the unsafe home PHP, and then copies the unsafe to the safe PHP. So now if we try logging out and we try the basic Alice SQL injection, we'll see that the account information we provided does not exist. And that's clearly that clearly displays that the attack that we once used is not able to be used anymore because of the protection we put in place. So let me go back. So for this demo, you can find the lab linked here, and there's also a video attached or on the same page, and there's all the sample information that I walked through should be on that page, and you should be able to find it. And I'd like to thank you for your time. If you have any questions about this or any questions at all, please feel free to email us, reach out to us over Piazza, or simply come to my TA office hours. Thank you all so much.